we're back. I think the game plan here is to pick up on a couple questions that Jim asked about, and then to maybe spend some time together looking and discussing this this data set from the other source. So, and then basically from this data set from Axiobase, and then it's a chance for us. I mean, the thing is, we have our objective is to basically help commerce get sort of. They always have problems that come up that have sectoral dimensions. So there's a sectoral dimension, having a little bit sectoral disaggregation level. But I'd be curious to get people's feedback on this. But let me begin with questions that Jim asked. Just first see, let me just double check it. I sent an email to the folks at Berkeley, but it was kind of last minute. So it occurred to me over lunch that I should ask these guys if they were around. Looks no one's come back. So okay, so okay, I first had an MPSG question from Jim. So let me just share my screen. So share. And then I'm going to we're here. First, we'll look at the GTAP WiNDC model. So this was a question Jim had. It's just something that always sort of comes up. It's going to be, it's always a challenge. And it's really has to do with the nesting structure of how these guys work. Maybe it's not in this guy. Let's see, no, it's a WiNDC model. It's the GTAP WiNDC model where this is. So there's an example of where we use this spanning up. Well, first of all, this one is the has both the spanning operator and the indexed set. So the rr.tl nest there, and then the pound sign down here. So there's two things that are sort of different here. And so rr.tl, when you put it in as a set definition, you're requesting that one nest be created for each element of RR. So that's this, that's sort of a index sets. And in this case, it's saying, well, I'm going to produce imports into region R. Imports come from regions RR, and each import has a fixed coefficient transport cost. So that's the PT of J input. So for each trade partner RR, we have to combine in a Leontief nest the cost of the actual import. That's the VXMD of RR to R. That's the import, together with the transport cost. And that transport cost is indicated in several goods J, but we want to have that good J entering at multiple places in the nest. And to see how this works, I can show you this. I put together a little example that shows how this works. So here, if we had, oh, I'm sorry, I made a mistake with this. I should have said. Sorry, let me just fix this so we have this guy together. So this should be G1 and G2. And this guy then would be, to do this right, this should be G1, G2, 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 and this could be G.TL sigma of J. So now we have it. So we have a set G, which has got elements G1 and G2 in it. And then we've got, so you can see the nesting structure down below. There's a top level elasticity, which has a substitution elasticity sigma S. And that shows up in the production block with an S colon. And then we have a value added nest of capital labor with an elasticity sigma KL. That's an arm. And we also have an Armington nest and sort of an A is the intermediate inputs nest. So that would typically be in Leontief in a standard sort of model. But so that's sigma A is the elasticity substitution between commodity inputs. But each commodity input has two varieties. There's the domestic variety and imported variety. And so there we use the G.TL. And I indicate G.TL because I want to put that as a subset. Each of the G's enters in nest A. So A is the nest. And so the way you read this is that S is always a reserve name for the nest. That's the top level nest. And then we start creating names. And so we say A of S says we'll add a nest called A as a subnest of S. And then it says introduced in KL as a subnest of S. And then we're going to, for each element of set G, we introduce a nest, which is a subnest of nest A. And so that's, you can see that in this model. We have the domestic input 1, the imported input 1, the domestic input 2, the imported input 2. And so those guys go in these two nests. And so this is what gets assigned. Oh, and here, actually do this better. I didn't do this right. So let me just do this. I'll do this one more time. Sorry, I keep changing stuff. PD of G. I'm sorry, I should have done it. I was, this is of G. I'm just giving you a canonical example. G.TL. One more time. This time for sure, Rocky. It's always the same thing. So now if we go back, I like Sumatra PDF because you don't have to, you can regenerate it right into there. So here's an example where we have G is the set G1 and G2. Each of the G's has a nest, has an elasticity of substitution for it. The sigma of G is the elasticity of substitution. It's the Armington elasticity between import and domestic. And so then we have this index that represents PD and PM. And those are both indexed over G, and those guys go like that. Now, yeah, so this gives us both of these guys. Now, if we wanted this to be, suppose that the import were another, just a final version of this, and I'll do this as a second thing. If we didn't have markets for M, but the imports were coming right out of foreign exchange, which might happen in the model, then you might, so, or if we did not have markets for imported goods distinguished, but only represented the foreign exchange cost. Through the market for PFX, we would have, so I'll just copy this guy. It's going to be the same as this guy. It's going to be begin end GAMS code. And this is where this stuff goes in. So here, rather than having PM, we'd say we want to have an input of PFX. But PFX, if you look at the nesting structure, PFX now, if we're representing the inputs of M1 and M2 as inputs from the foreign exchange market, we need to have PFX entering in both those locations, not just in one nest, what we have, because foreign exchange is consumed as the representing the imports of good 1, as well as the imports of good 2. So we have to say here, PFX bang G, that says span over set G, and then we'll input M0 of G, and that goes into G.TL. So that would then say introduce for each element of set G, have this M0 enter in, and that would give us a different format. Let me just say here, I'm going to say, just get these guys. Somebody will clean it up here. So now we're showing both the nest of inputs as well as that has both. So that there's the way it would look if you had a market for PM, or if you didn't have a market for PM and it was all through PFX, then you'd have to use the spanning operator to introduce the input of PFX in multiple locations. So that's sort of it's just a shorthand. You can't add a nest inside another nest unless if you were to write it out in a scalar fashion, then it would be fine. For example, this guy, you could just as easily have written, if you wanted to, if G were not varying from application, you could also write here, you could also, there would be nothing wrong with doing it in this case with G1. You could, so also you could basically, you could have a set that drives the inputs and then have a scalar definition of the nests up above. So that would be also okay. So the thing is that you could, if you have explicit definitions of the nest, you can have any structure you want to. It's all completely free, and the cool thing about it is it goes arbitrarily deep. So you can basically make it any nesting structure you want to. On the other hand, if you want to use a set, a .tl, you want to have that driven by a set, then you can't have a set under another set, and you can't. So basically, there's some limits on what you're able to do. So it's not completely, it's not complete, but it gives you a fair amount of flexibility. And just as I showed you, so this is an example that shows there, but also in the WiNDC model, you have the same thing. So if we look over here, it's the same thing, but it's in the M block. So in the M block, it says we have one, if we're looking at the inputs of good I into region R, we have a nest from each of the other regions RR, and within each the RR nest, we have inputs of the good as well as inputs of the transport cost, and that would capture the whole thing. Okay, so there's one sort of annoyance with this specification. And this goes back to the fact that in Fortran 77, if you wanted to store characters, you had to store them in integers. There was no character data type early on, and so the characters had a limit of 8 bytes. No, it was like 32 bytes was 4 characters, and so that meant that you could basically store 4 characters. So therefore, in my first implementation, and the implementation that we have, nesting assignments, the nest identifiers have a maximum of 4 characters. That goes back to the old restriction on Fortran 77. I've never changed that. So that means that you have to be a little bit careful. So if you have region names that are 16 characters long, you can't do this. So that's sort of an annoyance. I wish that were not the case, but that's just the way it works. So anyway, Jim, I don't know if that's sufficient, but that's what I have about that now. I don't know if that's.
No, that was helpful. I just thought it's useful to, like, if people haven't seen that and you encountered in code, you're like, what's going on here? So I'm glad you covered that.
So that's got that. Now
so in the new version, is that going to get relaxed then if and when that comes out?
Yeah, if and when that comes out, that will be relaxed. Yeah, I'll rewrite this guy like this. So, and then I'll send this to Martha. So I'll send this to Martha and share it with you so you can see it. Yeah, it's not something that shows up all the time, but there are certain situations where it matters, where it counts. And turns out that this nesting structure, the CES function, is much more general purpose than people realize. There's lots and lots of stuff that you can do with it that it's been around and the profession just has kind of ignored it. Like you can write down a model, for example, in trade. One of the disadvantages here, if all your trading partners, so you have a small share, if the import shares are relatively small or uniformly distributed, then the demand elasticity for your imports is the same across all your partners because they're all CES and it's all one elasticity. But if you go to a non-separable form, then you can have different trade elasticity. So you could basically do an arbitrary set of, so there's a lot more stuff you can do with a nested function. So MPSG gives you the ability to handle the stuff relatively easily. Okay, so that's that. I'm hoping that this will be relaxed. The new version of MPSG is there. The new version of MPSG, the cool thing is that it basically generates the documentation and getting the, and anyway, so that's in the works. I haven't talked to my co-author on this, just changed jobs. It's Florian Landis with my PhD student. So he has a new job in Switzerland, and I've not been bugging him because he was busy finishing up stuff he was working on at ETH. So I haven't talked to him in a month or so, but I'm hoping we're going to get back to that. I've taken some money from the MPSG research fund. I mean, MPSG makes some money. People buy software, the money, but it goes into a fund. I never take any money out of it. I just use it for funding research activities. And so I'm spending some money on buying some of Florian's time to help me with this, but I haven't bugged him in a while. So it's that's on my list to do. Let's see, there was one other question. What was the last one?
Well, so one point to go back on the next version of MPSG, I can't recall, were you adding more, I guess, flexible demand systems in that as well?
Yeah, so the idea on the new one is we have, let me see if I can show it to you. We have this very cool, this is related to a related paper. So I have a copy of the paper. Let me just see if I got it from Ed Ballesteri. Ed is going to, I recruited Ed to help me with this. So here's a draft of our logit. I'm happy to share this that I've got. So we have this new logit function. And the cool thing about it is it maps right on top of the CES. So this is one that we're basically working on. I'm happy to share this with people to show you what we're doing. So what's cool about it is that it's got a micro foundation story that goes along to it, but it's different than the standard logits that are used because it has this adding up. It matches directly onto the CET function and the CES function. And I don't know if we have a diagram here. So the cool thing is it gives you demand functions which locally are identical to the logit, to the CES function. So you can see the isoquants are identical there. But for large shocks for here, if we have a large price shock, you can see here that the isoquant is different. So I'm excited about this. Is I think that we'd rather think about these models in terms of what the local elasticities are and to be able to flag situations where we run simulations where the elasticity, the model results are being driven by the characteristics of the functional form far away from the calibration point. And that's what I like about having the CT or the CES and the logit both accessible through MPSG, and the cool thing about it is because the logit can map right on top of the CES, no changes required in the MPSG code. All the same information can be used to tie down the logit function. And that way you'll be able to run the model and press the button to get back the results from any functional form, either of these two functional forms. And I'm excited about this. So here, I'll share this with, you guys. Anyway, I'll send this along with the stuff. What I'm excited about this is that it's another functional form which has the same property that's globally regular and locally flexible. So I'm excited about this, but basically I'm trying to do, first thing to do is to get the code, the MPSG code to work. And the next thing is then to get it to be able to substitute the functional form in. So they're the same. The MPSG code, I think I've shown this to people before, is that if I look at the MPS version 2, here I have several models, but if I look at, for example, the GTAP WiNDC model, so here's the way the MGE model looks for the GTAP WiNDC. So these are all the functional forms. And so I haven't gotten to the point yet where I've written the parser to read this file and generate the intermediate file. But if you write the intermediate file by hand, so this is the MGE version 2 file, then it basically runs off of the bat include. So we're doing all the manipulation of this is done with GAMS. And so I write a bat include file that processes. So this declares So here we say we're going to define the structure. And so I do a bat include, okay, I'm going to tell you about the sectors. Here's a sector Y. Its the domain is GRS, and the description of it is production, includes I and G. So there's the sectors, there's the commodities, there's the consumers. And again, this is just, and it's a two-pass procedure. So first pass, we give the general structure, and then we give the explicit structure after the numerics get passed afterwards. So when I give it the general structure, I define using the bat include file for MPSG, I describe what are the production blocks, what are the inputs, what are the outputs, where these things go. So that all goes like that. And then I say, once I've down this point, then I have to run the MPSG code to do the compiler. So here I run the compiler, which will take the bat include that I've passed thus far, and it'll generate. And one of the cool things is, and I'll just show you that this works, is say GAMS MGE v2 underscore model.gms. This will go through and do the compiler, and there it's running LaTeX, right? So the cool thing is that then, so once it runs that, then it runs the documentation engine, which takes the code that was written for the thing, and it generates what this generates is a document. Whoops. Oh yeah, oh, okay. It generates a document that has the structure. And this is a document that just, notice it's June 15th, it got just written this second, right? So this all got written automatically by the preprocessor. So it goes out and grabs the structure and documents. And it's not, it suppresses the details because I'm not looking at this stage, I'm just looking at the structure of the model. What are the domains, what are the names? But it writes out what the market clearance and the income balance and the zero profit conditions are for the model. It's not, I mean, it suppresses a lot of detail, but it gives you some structure. It tells you what the, so D, so for example here, DPY in the GOVT tells it the demand for good PY sub I in the government and so forth. So it tells you, it's basically enough to see what the general structure is. It's not, the explanations is not completely clear, but it's, you know, in terms of documenting, if somebody insists that they see what the model is and they don't trust what the system is, this would generate that. And then in addition to generating the code, the last call then says, then this also generates, in the MPSG thing, it generates the model. And there's the model code that gets generated on the fly by this guy. And so this has the variables, they're all the sets, so it's extracting what the domains are. So it's readable. It gets generated a GAMS code, which is algebraic. It's not so easy to read, but the names are all interpretable. Like PD underscore X is the input of commodity with a price PD into the sector named X, and there's a domain that controls it. And so it's not completely like, you know, but I've worked on this for quite a while and getting this guy to work. It does actually, GAMS can process this, but we still have to, we haven't finished getting all of the engine running for the functional forms. So we suppress all the functional forms, and I represent them by these variables, but I have to write in, we have to finish off the code for, so we made a pass at this last year. I worked really hard on this for a few months, and then I set it aside, and I'm hoping to get back to it. It's on my list for things to do this summer. Anyway, so that's the thing, but I'll send along the code about the logit function, and I'll yeah, so that's where we're at.
Thanks, Tom. That's great.
Yeah, it's a multinomial, nested multinomial logit, but it's different. It's actually, we make a different assumption that most logit specifications that are used in transport or sorting models, they typically have to have an outside good. So if I'm going to choose inputs to labor versus capital, there's some cost that involves choosing one good or the other. And there's a random realization of a cost, which has a price, which is not the good. But notice in the CES model, it's all a general equilibrium model. The cost is if I use more labor, then I can use less capital. The trade-off, the cost is entirely denominated in terms of the inputs. And so this is the first logit function I've seen where I make an assumption that gives me exactly that same property. So it's trading one off for the other. And that's what makes it so that it maps onto the CES. And within the economics profession for the duration of my career, people, CES, if you're using CS, you sort of apologize about being so lowbrow. And I think the profession basically has just missed the boat on this, that basically CES, when you have non-separable functions, it's locally flexible in the sense you give me a Slutsky matrix, which is convex, I can give you a model that matches that. And it's globally regular. And there's no other function other than this new logit function that has that property. The logit function also has the same advantage. So I'm big, but the logit function it's messier. It doesn't have a closed form expression for the cost function. So you have to have a zero profit condition to assign the cost function. But it's cool. I like it. That's my problem is I'm getting old and I can't stay up late anymore, but I still have things I like working on. And so I wish I had more time to work on this, but I haven't in the last month or two.
His last question was about EMP.
EMP.
And what is the potential value of EMP for CGE model?
Good question. EMP is one of these things that basically is a notational device that makes it possible to better communicate to the solver the structure of a complementarity problem that otherwise would be very difficult to write down. Classic example would be one that an example Jim gave yesterday, which was the classic one is the diagonalization technique for solving for optimal tariffs. So with EMP, the model he wrote down where you had to do something procedural in GAMS to solve the model. So you have to write a loop you're essentially writing your own solver using a high-level solver on top of it. EMP makes it so you don't have to do the looping. It'll handle it automatically. And so EMP typically works nicely for handling problems that otherwise you'd have to do it yourself. You have to roll your own. The challenge with EMP is that basically the class of problems that it's most intriguing for are ones that are like the classic EMP would be one that says optimal tariffs or optimal taxes. And the problem is if you have a true complementarity problem and you're optimizing over in the instrument space, oftentimes the problem is very difficult to solve. It's basically NP complete. It's like you don't know. A classic example would be one where if Jim's the optimal tariff, the Nash equilibrium tariff works nicely when you have a point-to-point mapping, when it's all Armington goods and you're trading off along a smooth frontier. But if goods are perfect substitutes, then it's hard to know which frontier you're going to be on, and it's hard to get the diagonalization doesn't work. But in cases where the diagonalization doesn't work well, the EMP algorithms oftentimes have trouble too. So the challenge with EMP is actually in search of an application that's sort of the killer application. Now, Ferris is now working with, we have a paper that's sort of in nascent form, working on using EMP to capture attitudes toward discounting in climate policy. So if you have if you want to discount future damages at a lower rate than what would be implied by your intertemporal choices on the macro side, where you basically want to discount future damages at a lower rate than investments, then that's a case that you have an EMP model, and so we have an EMP specification. And that application, again, that's an application where if you do it correctly, you can write the code down in GAMS, you can get this to converge through a simple diagonalization procedure. But I like the EMP thing because it makes it possible to write the model down in one shot, and basically it's easier to communicate what you're doing. To be honest, I feel a little bit guilty because the challenge is that I'm here with Ferris and I can go and knock on his door and bug him about stuff. And that's the way we have and I can, again, I'll circulate the paper. We have a recent paper we published 2 years ago on using EMP for solving dynamic stochastic models for dynamic programming. And essentially in that paper, we show that the Bellman equation, which is sort of a part of macroeconomics, you can solve that as a complementarity problem, and you can solve it in one shot. So it gives you the potential for rather than doing Bellman and iterating, you can actually just set up a complementarity problem. And so you can do like a few Bellman iterations and then go right to the solution. It sounds exciting. The problem is with those dynamic programming problems is they're messy and really hard. So even though we show the EMP is sort of I think it's cool way to think about it, but I'll include that paper. We'll send that paper along. So yes, I think EMP is cool. If I were a junior guy working on something, I think that'd be a cool thing to learn more about. I haven't found the killer application yet. Thanks, Jim. Really great. So
Thanks, Tom. Much appreciated.
yeah, sure. So we'll include that to go around. So the last thing we had for the group was sort of to collectively look at this Exio-based thing. And I'm happy to share, we work on things all the time. This was for we had a thing on border measures. Let me just see if I can find this. So we had a thing on border measures where the people working on border measures, they care so much about the border measures for selected industries. They don't care if we tell them, no, there's no international trade data set, or we don't, the other thing you can say is that if I'm working with GTAP, the usual place, and I have a paper from several years ago where we basically worked with the HS6 data set that's distributed with GTAP. Let me see if I can find that. I can point you guys to this. Is the I'm just getting rid of stuff here. So HS6. So I would say that normally I would think if people ask for going below the level that we can cover for trade data, I usually say, I usually point them to TASTE. And so TASTE is a GTAP resource. The most recent version is for GTAP 10. It's 1.6 gigabytes. It's I used it for, it's done by very smart guys. So David Laborde is great. Mark Horridge, of course, is like the smartest guy in the world at programming stuff. Janine is another one of the Australian group. These guys are super. So they have a tool that they use that's a partial equilibrium model. You can grab this stuff in GAMS. It's like there's a little bit of messing around for getting the data, but this gives you a very detailed, at the HS6 level, you get bilateral trade flows. The problem with TASTE is that you don't get any information about what the structure of the domestic market are for these goods. So I don't know what fraction, I can see how much gets exported, but I don't know how much the good gets produced domestically for domestic use. It's basically just it's based on various trade statistics, the McMap data set. So the problem is that incorporating this stuff into a GTAP model involves making some heroic assumptions or some sort of assumptions to make it possible to close the model off. And I was always nervous. I mean, Hertel and I did the stuff on dairy trade and tariff quotas in the setting. And I think we got some interesting insights, but I was always uncomfortable about how we specified the domestic structure in this model. So then for this work on border measures, we went to the usual, well, we ended up going back to Exio base, and I hadn't been to Exio base like in several years. I'd been back there. I noticed on the email exchange, I reported some challenges that I had with using the data in 2015. So it had been whatever 7 years since I'd looked at it. And man, this data set has gotten a lot bigger and a lot more carefully documented than it had been before. So if we look at this, we have Exio base 3. We have both monetary statistics and hybrid, which basically includes lots of environmental indicators. It has gender, employment. It has lots and lots of information. I haven't taken the time yet to study their documentation or publications, so I'm a little bit. I feel like I'm really not ready yet to answer questions about it. All I can say is that it looks okay in the sense that I take the data, I download it, I get a handshake on the economic data, and furthermore, it's possible to get this stuff to map through onto the so let me just see if I can show you. Well, first of all, if we look at the data, here are the data sets. So this has got 267 megabytes. This is the monetary side of the model. And then there's also the non-monetary statistics, environmental statistics. And this starts from 95 and it goes through page 2, I think it goes through 2017. So what's exciting about this is that we have 2017 in the GTAP WiNDC when we get GTAP 11. Oh, wait a minute, I thought I had one. I had one from Aurora Region 1. This says 2011, but I think I'm not sure where I found, I can't point you to it, but if you go and look around, you can find a place where you can get 2017. So it's possible we can get a data set that maps onto WiNDC GTAP. It would be possible to use as a means. And what's better about this than the TASTE data set is that it has stuff both inside the border and across the border. Now, the challenge I see with this is that it's one of these data sets that, you know, you've got to be joking. It can't possibly have. So it's not. It basically tells you quadruply indexed trade flows. So it has flows. Let me just see if I can find this. I got to find out where I was. This is GDX data, Exio base. Oh, wait, I'm sorry, it was a different directory. Handshake, there it is right there. So now if I look at my model, so this guy has a code that basically reads the Exio data set, and I'm happy to share the data files that pull down. If I look at the GDX file I have, GDX data has Exio full, which is 23 megabytes. So this guy, if I look at what I've got, I've renamed things. And the one thing I did was in GTAP, they say by commodity, you have gross trade in that commodity from region 1 to region 2. So, you know, so here we have, if I look at this VXMD, their data set, and they have using 2-digit labels, but they have from region. So this tells you what the regions are. So they have from Austria to Belgium. So they have a whole bunch of regions. And then it has also, if I look at set, that's our regions, 49 regions. And then it has 163 commodities. And this is G includes set, the final demand includes household, NPISH, government, fixed capital, inventories, and valuables. So this is basically a data set. Now, this is not the format that they put it in. They have quadruply indexed, not triply indexed. They actually say commodity from region to sector in region. So it's actually, they have all these flows. I just don't believe that data gets collected. And when I took the data set and did a little input-output calculus of how much the Chinese value-added share of final demand, I got no differences. So it looks to me as though the quadruply thing is simply they've done proportional scaling of the flow. So the way I approached this was I took the Exo-based data set and then I mapped it onto the identifiers from GTAP. And then I wrote a little code to go in and to pull in, if I look at what the sets are, there's the data set. I go in and I wrote a little thing to do a rebalancing, a recalib.gms. And so this has, for example, in GTAP, we have CHM, and in Exio base, the corresponding sectors are chemicals and chemical products. They have mineral products, and this has non-metallic mineral products and cement. And then ferrous metals has aluminum, iron, and steel, non-ETS, non-ETS, and so forth. So they have a bunch. They have a breakdown of 3 or 4 sectors per guy. So I basically took these guys together, and then my recalibration code basically just split out. So here I'm doing a splitting out of my target to what. Anyway, so I wrote a code that's like this. It's very similar to the stuff we do in WiNDC, and I'm just using least squares. But I'm kind of excited about this, and so and because it has all these other indicators, I think that this is the sort of thing that I think would be of interest to the Commerce Group. And it's not that the data set is better than GTAP, but I think that because it has both trade and something about production structure, that we could nest this within GTAP. Yeah. So we can take GTAP, and then, so my proposal is to build a version of this where we respect the GTAP categories. So if you take a GTAP Exio-based data set and you say aggregate to the GTAP sectors ideally, I'd like it that it aggregates exactly to the GTAP data set. And then we're leaning on Exio base just to split up the sectors that are below GTAP. So I'm thinking about GTAP being in charge. So GTAP owns the data. So we're going to respect GTAP. We're not going to trust Exio base for GTAP stuff. So all the stuff in GTAP is there. And then we looked at Exio base just for the ones where there's an exact partitioning of a GTAP sector into subsectors. We rely on Exio base to do the partitioning. And the advantage relative to this is that, let me just see if I can find, I know that, Jim, I know that it's there because I've been working on it. Let me just see, maybe it was 2014.
You know, I mean, on the about page, it looks like they say the original data was available through 2011, and they do something called nowcasts to go to 2020 and beyond. I'm not sure what that means.
It means that they make up numbers.
Well, no, but I'm guessing there's more recent data that they have, so I'm not sure how old that is. But yeah, so I looked at, I guess there was some paper that compared like GTAP and WIOD and Exio base. This is probably like 4 or 5 years ago. But yeah, no, I think it seems like this is a worthwhile application though to break out sectors.
The thing is that it's more just about, you know, we have these interior point codes that can do least squares really fast. We have tools. It's not about the computational problem. It's just the time cost of getting your eyes on the data and figuring out what maps and doing the work. That's all it is. Once you've got the code written for doing it, it doesn't take much work to keep it maintained, right? So I think this, and what I'm hearing from, I mean, you go to do things from projects with particularly commerce, they're always being asked about very specific things. And invariably our answer is, we can only give you GTAP numbers. And they say, well, that's all you have, then give us those numbers. It's like, if we have this other data set, why don't we produce a tool? I'm not saying replace GTAP. I'm saying go below, let's do our best estimate on this using this as a starting point. So that's, anyway, I'd be curious as to on the call if anybody else has worked with that.
What environment variables do they have in there?
Oh, okay, I'll open.
Is that, do they have like emissions and things?
Let me open this up for you because I was shocked. I was completely shocked by this. Yeah, I was completely shocked by this. Yeah. It takes me a second because I gotta go. It's on my. So I'm gonna share my screen. I have to go to my other, but I think you guys can see this. All these technologies, I don't know how this stuff works, but it basically works. Oh wait, I'm sorry. What the problem is, I need to. What's that? I'll show you in a second. Question. I can show you. Just you open up Chrome and you do Siangé Bridge. And that's a bridge I built in 1977. Yep. So let's just see. Now if I go, I think I can now go over here. I just want to show you this stuff because it's cool. Yeah. So this is going to be So this is, I have IoT 2017 and I have IoT 2014, and it has industry by industry. It has all these different choices, right? And you can see they're monstrous. This guy is like 760 megabytes. It's huge. And then if I go to satellite and I look at read F, those are the goods. And there is the industries. There are the regions. Wait a minute, I had another one. F was the one. So now we have taxes less subsidies. There's a few economic things that are basically royalties on land, resources, operating surplus. I say set font. I'll make this bigger so you can see it. So, but then it has employment, low skilled, medium skilled, and high skilled, male and female. You can impute wages because they tell you hours. Vulnerable employment, I don't know what that is. And then we have combustion, CO2, air combustion, and then it has all of these trace gases as well, as PM 2.5. Like there's lots of details. And then these guys are doubly indexed. I don't know exactly what's going on. I haven't sorted out the environmental stuff. I started to look at it and I couldn't figure out how the thing maps, but basically the stuff is all, there's lots of stuff there. It's like really, really a lot. It's got many things. And I'll just say it took me some effort to do this. And this is one of these things where I'm a dinosaur, right? So dinosaurs do things differently, right? So it's like, I went back to the guys, it's the, you know, the data scientists who you program in Python who own the world, but we protest sometimes, right? So, because I sent the guys at GAMS a copy of this data file. I said, show me how you read this thing in GAMS, and they came back with a big Python code that I couldn't understand. And I said, well, what about these 4 lines of command line, these command line scripts and using CSV to GDX? Because they want to basically disable CSV to GDX and make you use Python. It's like I'm saying, no, this code runs in 1/4 or smaller, less time, and it's also much shorter, right? It's like the Python script is 3 pages long and has all this stuff I don't understand. Whereas here I say tail lines equals +4. It says chop off the first 4 lines, because the problem with this data set is that it's got not 1, but 2 labels on each column. So it's got, and there's no way to read that. So I just chop off the label headings, and then I use CSV to GDX to pull off different columns. And then I have to write some code to pull this in. So I basically have to, and here I'm doing an allocation. The thing is complicated is I have to keep track of, I'm relying on this being a dense data set where I know where the sets are, and I can then map it from the data that I read into here. So anyway, this is what I currently have. It's not intended for general consumption, but it actually works. So I'm just excited about the environmental, the male female dimension, and these other indices. I have to start reading that, but I'm kind of excited about the fact that it seems like this is something that, because I've been communicating with the folks at Commerce about figuring out ways. They've been very generous at supporting us, and I've been thinking about ways that we could basically help them more. And Natalie asked me what I knew about, you know, they really are under the gun to have more detail. And so I think that this is something that we're hoping we can do together with them, is to produce a version of the data set. I'd say the other thing I'm interested in doing with this is producing a version of WiNDC that can do partial equilibrium analysis too. So basically, if you're looking on one sector, you can pull out a part, and we'd like to have a few of those models around that don't require, it's not, you want to have it be so you're not required to run everything. You can do it at different stages. And the idea, you could look at the same question from several different perspectives. So yeah, so that's what I have. Again, happy to share this with you guys.
Hey, Tom, that looks really useful. I mean, I saw as you're going through the code, they were breaking out blast furnaces versus electric arc, and that was a big, and still is a big topic for us. So yeah, that looks, folks will be interested in that.
Yeah. I don't know this group, but I think that I suspect if they're like the, basically there are these European groups that are basically basically input-output modelers, and they're careful about writing what they do. So I think it's good. I mean, whether or not, undoubtedly we'll get the pushback from GTAP that, oh yeah, that data is not reliable, this or that. But if your game is to run one aggregate primary metals versus having, if you're trying to look at aluminum, then you'd like to have some data for aluminum. So I think that the way to defend the analysis is the policy being that whatever data set, disaggregate data set we generate, if you aggregate it that it's always possible to aggregate it to the GTAP sectors. And if you aggregate it to GTAP sectors, you get back GTAP. So that's, I think if you do that, then okay, we're doing the best we can, right? Any other questions? I'm open to. Well, we'll yeah. So we'll keep working. Okay. So thanks everyone. Sorry to be